Good day, everyone. In this lesson, we are going to learn about how the operation of refrigeration, that is, how it works, and also how the first law of thermodynamics apply in the course of its operation. Please don't forget to like, share, and subscribe to the YouTube channel. We begin with a brief overview of refrigeration system. A refrigeration system is a system designed to transfer heat from a low temperature space to a high temperature space, thereby cooling the low temperature space. Some key components of this system are compressor, condenser, expansion valve, and evaporator. Let's delve more into the key components of the refrigeration system. We have the compressor, which compresses the refrigerant gas, increasing its temperature and pressure. The condenser dissipates heat from the refrigerant to the outside environment, causing it to condense into liquid. The expansion valve reduces the pressure of the refrigerant, allowing it to cool and expand. The evaporator absorbs heat from the refrigerated space, causing the refrigerant to evaporate back into a gas. Note: a refrigerant is a substance, typically a fluid, used in refrigeration systems to absorb heat from one area and release it into another. On the screen are images of the components. We have the compressor, the expansion valve, the evaporator, as well as the condenser. We move on to how a refrigeration system works. The refrigeration cycle operates continuously, involving the transformation of the refrigerant through different states, from gas to liquid and vice versa. The cycle begins by the drawing in of low pressure refrigerant gas done by the compressor, of which it compresses it into a high pressure gas with a high temperature. This gas then travels to the condenser, where it releases heat and condenses into a liquid. The liquid refrigerant then passes through the expansion valve, where its pressure drops, cooling it down. Finally, the cooled liquid refrigerant enters the evaporator, absorbing heat from the refrigeration chamber, vaporizes and returns to the compressor. It is a continuous cycle. Some applications of refrigeration systems in everyday life are: refrigeration systems are widely used in food preservation, air conditioning systems, in industrial processes. Then, on the right of the screen is a pictorial summary or illustration of the operation of the refrigeration system. The compressor draws in the low pressure refrigerant gas and compresses it into a high pressure refrigerant gas of high temperature. This refrigerant gas is then condensed into a liquid refrigerant at the condenser, where it undergoes expansion at the expansion valve for cooling to take place. The cooled refrigerant moves into the evaporator, where heat exchange occurs, hence taking out the heat from the refrigeration area, that is the low temperature space. The heat vaporizes the refrigerant, where it returns to the compressor for the cycle to continue. Let's get into the second part of this lesson, where we get to know the first law and how it applies in the refrigeration system operation. The first law of thermodynamics, it simply states that energy can neither be created nor destroyed, but can only be transformed from one form to another. W is negative because work is being done by the system onto the surrounding. Application of the first law of thermodynamics in refrigeration. In the refrigeration cycle, the total energy input equals the total energy output. Also, the refrigeration system transfers heat from a low temperature area to a high temperature area whilst work is being done on the refrigerant. With regards to component by component, the first law is also applied. Compressor. The energy used to compress the refrigerant gas is transformed into potential energy in the form of increased pressure. Also, it transforms electrical energy to mechanical energy. In the condenser, the refrigerant loses heat to the environment, hence reducing the internal energy of the refrigerant for condensation process. Therefore, the energy lost by the refrigerant is equal to the energy gained from the compressor plus the energy absorbed from the refrigerated space. The expansion process is an adiabatic process, namely, no heat transfer occurs, hence no work done. The evaporator absorbs heat from the refrigerated space, causing the increase in internal energy of the refrigerant. The heat absorbed from the environment equals the change in internal energy plus the work done by the compressor. The first law can therefore be expressed for the refrigeration cycle as energy input minus energy output minus the work done. In conclusion, this lesson has illustrated how the first law of thermodynamics dictates how energy is conserved and transformed within a refrigeration system. By understanding these concepts, engineers can design more efficient systems that effectively manage energy use with the goal of enhancing performance as well as operational costs. Thank you for joining. Don't forget to like, share, and subscribe.